Hi everyone, my name is Isnur and I'm from Group 3. My teammates are Jingtong, Kaifeng, Banesh and Shivikin. Before we dive in deeper into our bridge model explanation, I would like to ask one question. What comes to mind when you see this man? I am guessing most of you thought of the Mona Lisa, right? But here's an interesting fact. Leonardo da Vinci wasn't just an amazing painter, but he was also a polymath, which makes him an amazing engineer. Stay tuned as we reveal the interesting concept behind his bridge design and how we incorporated it into our model. Here's our bridge model schematic diagram. It has 7 lateral sticks and 7 horizontal sticks following the guidelines. The dimensions are 40 cm in length, 8 cm in width, and 17 cm in height. For our design, we combine 3 main shapes, the arc, triangles, and rectangles. The arc shape is great for evenly distributing weight, which is why it is used in so many strong structures, while triangles are super stable and can handle heavy loads without bending or collapsing. Lastly, rectangles are practical for creating flat, stable surfaces which are important for functionality. By using these 3 shapes together, we design a bridge that is not just strong but also efficient and functional. For the base of our bridge, we added cross and diagonal bracings. As you can see here, there are cross bracings and diagonal bracings. The materials we used to build the bridge include wooden bamboo skewers, sandpaper, pencils, a cutter, a 30 cm ruler, and a hot glue gun. Now, let us walk you through the process of how we constructed the bridge. Firstly, we began by measuring and cutting the wooden skewers to match our design dimensions. Then, we smoothed the sharp edges with sandpaper. For the arc, we took inspiration from Da Vinci's bridge design. Instead of bending the skewers, which could be risky since wood isn't flexible, we kept the arc structure straight and strong. Next, we constructed the surface, where live loads like vehicles and people would be applied. After completing both the arc and the surface, we combined them and added trusses between the sections for additional support. To further reinforce the structure, we added more trusses above following our design plan. This design was inspired by the Iron Bridge in the UK, a cast iron arch bridge that crosses the River Severn in England. Opened in 1781, the Iron Bridge has stood the test of time, and its use of trusses for support has been a key influence in ensuring both strength and stability in our own bridge design. Finally, the big day, which is the load testing day. At first, we used the short load hanger, but then we realized our bridge could support more load, so we switched to a longer load hanger. This may have affected our results as we had to redo the load test, and the previous load could have caused some minor deflection or rotation. From the start, we designed our bridge with aesthetics in mind, ensuring it had its own unique visual appeal without compromising its functionality. In the end, we achieved a final result of 340 Newton plus minus, including the chain and the load hanger weight, showing that our bridge not only looked good but was strong and reliable too.